This is video 661, and the goal here is to understand the basics of vectors and how we represent vectors in the coordinate plane. So the first few parts here, many of you saw in class on Monday, but we're going to take a look at it again in case you were absent or in case you didn't get the notes down. So the first thing is the definition. The definition of a vector is a quantity having direction as well as magnitude. Now direction, of course, is relative to due north. It's the way you want to think of it. Okay, so the direction of 0 would be in the direction to the north or straight up. 90 degrees would be a direction to the right, and so on. So this direction over here would be a direction of 270 to the left, due west. And the direction, of course, straight down would be 180 degrees. So direction is an angle, and we'll talk about how to find directions. But that's the first part of a vector. The second part is a magnitude. A magnitude is really talking about the power, the speed, or the velocity of an object. So how strong is that object? And it's described as it is found by looking at the length of the vector. So the longer the vector, the more power it has. Now some examples. So if we wanted two vectors that are equal vectors, they would have to have the same direction and the same magnitude. This is vector u, and this is vector v, and they are equal vectors because they have the same speed, the same magnitude, and direction. Notice the symbol that I'm using here to talk about the vectors is this sideways, this arrow without the bottom part of it. If we did a full arrow, it would be a ray. Those are equal vectors. These are equal magnitude vectors. So again, these will have the same magnitude because they have the same length, but they have actually different directions. So they are not equal vectors because they go in different directions. Now, the way we talk about magnitude is we use this double bar notation. If I was asking for the magnitude of u, I would show it with this double bar. So if I wanted to show these two magnitudes were equal, I would write the following statement. The magnitude of v equals the magnitude of u. The final example, we'll look at ones that have the same direction. If we look at v, it's going in this direction. If u were going in the same direction, these two would have the same direction, but different magnitudes. Because they're parallel, they're both pointing in different directions, but v is definitely longer, therefore stronger than u. Now let's talk about how we're going to describe these. So first of all, the common notation. When we use the letter j, when we're talking about a letter I and j, I is the unit vector whose direction is along the positive x-axis. So that's this vector right here, and it's got a length of 1, and it goes completely east to the right. Okay, so this is the horizontal unit vector. J is the vertical unit vector. So again, it's only 1 unit long, but now it goes straight up. So it's going to go in the positive x and y directions here. If it was a negative I, then of course it would point to the negative direction with x. So we use I and j to help us describe vectors that we're going to draw in the coordinate plane. And we'll often use the coordinate plane to help us kind of visualize what's going on here and draw different vectors and resultant vectors. So the way we'll talk about vector v is we'll talk about it in terms of I and j. Here's vector v. It has a eastward direction, or to the x direction of a, so we call it ai. Vector I, of course, because I is the x direction. And then it has a vertical direction, a northern direction of b. So the vector itself is described as ai plus bj. Okay? It's describing the length to the right, the length to the right, and the length to the left. Upwards, excuse me, because the j is upwards. So that's how we describe vector b in the coordinate plane. How far to the right, how far up. And that's how we'll use to draw it as well. And of course, negatives are logical here. So if it was a negative b, it would be going downward, and a negative a would be going to the left. Now a couple, so this kind of reviews that a is the horizontal component because it's with the I, and b is the vertical component because it's with the j. So it all links up with what we just talked about with the unit vector. But what's nice about describing it this way is we can actually find the magnitude with ease here. The magnitude of the vector would be described as the square root of a squared plus b squared. And that all derives from the Pythagorean theorem because this length of this vector would be a squared plus b squared would equal to c squared. Of course, we got to take the square root. That's why we have the square root of a squared plus b squared. So that's how we'll find the magnitude here. It's all about Pythagorean theorem, so it all kind of links to trigonometry in that way. So let's take a look at an example to kind of make sense of some of this. So we're sketching the vector that says negative 2I plus j. So negative 2, that's my horizontal direction. So I'm going to go negative 2 to the left because it's negative. And this is my I vector. My j vector would be up 1 because it's 1j. So I'll go up 1 from that point. That's my resultant vector. We'll start at the origin since that's where I started. This is actually my vector v. Okay, because I added negative 2I plus 1j to get to my resultant vector v. The magnitude is negative 2 squared plus 1 squared, because again we're doing Pythagorean theorem, the square root of that. So it's the square root of 4 plus 1, which is the square root of 5. This is the magnitude. The magnitude of vector v is square root of 5. So it's really just knowing what I and j stand for. Once you know that, it's quite simple to sketch a picture. Let's take a look at another example, because now we're going to have some where we're not drawing them from the origin. Sometimes the vectors will be kind of out in space if we're talking about a boat taking off from a certain spot on the river. We're not always going to start at the origin. So let's take a look at another way that we'll talk about this. Sometimes they'll give us 2 points, P1, which is the point that's at x1, y1. So it's some point out in the middle here. And they'll tell us that's the initial point. Okay, that's the initial point. And then they'll tell us the terminal point. In this case, it's P2, which is at x2, y2. And that's my vector. It goes from P1 to P2. So if we want to describe this vector in terms of I and j, meaning the horizontal and the vertical, well, the horizontal, of course, has to do with the x values. So we would take x2 minus x1, find out how long that length is. So my vector v could be described as x2 minus x1 I, because I is horizontal, plus the vertical component, which is y2 minus y1. So how long is that piece? It's kind of like a sloped triangle. So y2 minus y1, j. That describes the vertical component. That would describe my vector v. Now, how does this matter for the long run? Well, if I wanted to do the magnitude of v, I would simply need to find these two lengths and square them and square root the sum. So it would be x2 minus x1 squared plus y2 minus y1 squared. It's just the distance formula that we've talked about earlier in the year, because it's really the length of that segment. V is really the magnitude of this vector. And that's how I'll find the magnitude. So again, this is best understood with an example. So let's take a look at another example so we can make sense of this. So if we're getting a vector that's from initial point -2, -2, we'll go to -2, -2. And terminal point, so it ends at 2, 3, 2, 3. There is my picture of my vector. Now a picture is easy because now we can actually literally count how big this vector is. This is my I component, and this is my j. I and j. But what I really could do is just subtract the i's and j's. I could do 2 minus -2. to get my I value, to get how big the I is, which in this case is going to be 4. And that is a length of 4. So my vector v, my resultant, is 4I plus, now what's the j value? Well, it went up and I could literally count it. So 1, 2, 3, 4, 5. It's 5 vertical. Or I could subtract these two numbers. 3 minus negative 2, and I can get 5. So this will be 5j. This is v in terms of I and j. So I've just answered this question, where I is the horizontal vector and j is the vertical. Now if I wanted to find the magnitude, it's much easier once I have this, because I'm simply going to square these two, 4 squared plus 5 squared, and square root the result. Because that's how I find the magnitude of vector v. And this will give me the square root of 16 plus 25, which is 41. And that's my magnitude of vector v. So pictures are really helpful at the beginning here, but over time you'll want these formulas. You'll want to know how to find these without a picture. So let's take a look at your checkpoints. You're finding the magnitude of the vector, so try and draw a picture, and then you will find the magnitude of a vector with initial and a terminal point, and try to describe the direction. We're going to talk more about direction in the next video and how to find direction and the angle of direction so that we can analyze real-life situations. So choose one of those 4 options to describe the direction and put those answers on the checkpoint. So good luck, and I hope this was simple application and how we're going to talk mathematically about these vectors in this chapter. So good luck, and we'll see you in class.